Hello Year 9 and welcome to the second part of this lesson on electricity supply, and today we're going to be looking at wiring a plug. If we were in school at the moment, we would all do this practical and have a go at wiring a plug for ourselves. It's really important to understand how to do that safely. Part of that is knowing which wires go to which pins, and the pins are where we actually connect the wires so they go through to the pins that go into the wall. You'll see there's a blue wire to the left, a brown wire to the right, and straight up is a green and yellow wire, and they are the neutral, earth and live wires. And in fact we have to make sure they're the right length because we don't want them too long, otherwise they can curl up inside the plug and wear away. And you need to make sure the ends are carefully stripped so you get a really good connection between the copper wire, which is a conductor, and the brass pin, so that you're actually getting a connection of electricity through to your appliance. It's really important as well to make sure that the cable grip is in place with the right part of the insulation all the way through it, so that you're not wearing away any of the wires, because if two wires come into contact you can get a short circuit and that could cause a fire. Here's a diagram of exactly the same thing, just a little clearer. So you can see you've got a blue wire going to the left and a brown wire going to the right, with the earth going straight up to the top, and the fuse is attached to the live pin. So the point of the earth wire is to protect you in case something goes wrong with the appliance. We only use these on appliances with a metal casing, and if the live wire were to become faulty and become attached to the casing, then it would mean that the outer casing would be directly connected to the mains, which would obviously be very unsafe. So the earth wire provides what we call a low resistance path, I want you to remember that little phrase, down to the earth, so that if you were to touch, say, your kettle or your heater and the live wire attached to the casing, then rather than flowing through you, the current would go down to earth. The fuse is there to protect the appliance. The fuse is a very thin piece of wire and it breaks if the current gets too high. Again, very important to remember, it's breaking the circuit if the current gets too high. It doesn't control the current, it just breaks the circuit and stops the current. So up on the top right you can see a typical fuse, and in there you can see the little tiny wire in the centre that would burn through, and that's what we see in plugs used to protect individual appliances. That's in contrast with the picture on the bottom left there, and that's what we use to protect the circuits inside our homes. It's a fuse box. As you see, we no longer keep individual little fuses in that box, which we did used to do a long time ago. The problem then was that if you needed to replace a fuse, you had to make sure you had one in your home, and then you had to go and change out the old one and put the new one in. This is a much quicker and more efficient system, and they've called it an RCCB, sometimes also called an RCD, and it works more like a switch. It's very like the little button we have on the front of our power packs in school, where if you overload the current it pops up and you have to reset it. The same thing happens here. The current coming into your home is too high, then one of these fuses, instead of blowing, the switch trips, and then to reset it you just flip the switch back. Much simpler. So here's a typical exam question. You often get questions about electrical safety because it's obviously very important, and in this case they're showing a kettle with an earth wire, live wire, neutral wire there, and they're asking us if a fault makes the metal case live, the earth wire and the fuse inside the plug protect anyone using the kettle from an electric shock. Explain how. And in this case they're only offering 2 marks, which means they're not really looking for a very in-depth answer. Okay, so I divided the 2 marks between talking about the earth wire and the fuse. That means I'm going to hit both parts of the questions there. It's only 1 mark for each bit, so very simply at the top they want you to say something about the fact that the current from the live wire ends up flowing through the earth wire. In a longer question, if it was a couple more marks, I would talk about the fact it flows through that low resistance path to earth. The second mark is for talking about the fuse. Here they simply want you to say that the fuse melts or blows or breaks. And then again, a longer answer question with more marks, I will talk about the fact that if there is too high a current flowing, mark 1, then the fuse will blow, mark 2. So once you've been through this presentation and the other little video which has come up for this homework, then you might also want to have a look at these 2 web links below. There's one for bite size and a YouTube link as well that you might find useful if you need something extra on top of these videos. I've also put together a sheet. There's some questions on there with a mark scheme, so you can have a go at some exam questions and then check your answers yourself at the end. They're not particularly lengthy. Finally, there's a quiz on Show My Homework that I'd like to try so I can see how you're getting on. Best of luck.